So for functions with radicals, you're going to take everything we've done up to now, and essentially we are doing function notation with square roots and cube roots. So the same function notation that you did in Math 101 or in high school, where you have f of some number, you take that number and you're going to input it in place of x, and then evaluate or simplify that expression. One thing to keep in mind is make sure you pay close attention to the directions. If the directions say to estimate the radical or round to 2 decimals, you're going to put the thing in your calculator, get out the decimal version. If it says to write it in radical notation, you're going to leave it in square root. So make sure that you distinguish how your answer needs to be put in. For the most part, if it starts in a decimal, you can end it in a decimal. If when you plug it in, it gives you this nice radical like this square root of 12, or this square root of 24, or this square root of 49, that's when you're going to simplify it and not give me any decimal. But just make sure you read the directions. Also, something to keep in mind in terms of domain is if you see brackets, or if you see greater than, less than, or greater than or equal to, if you see greater than or equal to or less than or equal to, that is when you're going to get brackets on the numbers. Now for this section, it will always be brackets on the number, and then the infinities will always have parentheses. So our first example is to find the domain. So off to the side, I've already wrote that when you are finding the domain of even roots, that is when you will set whatever is inside the radical under the house, set it greater than or equal to 0. And that's because square roots, all even roots, have to be positive or 0. You can have 0 and then it has to be bigger than 0. So you're going to actually force this thing to be greater than or equal to 0. So you're going to take whatever is under the square root house, in this case negative x plus 5, and say that that must be greater than or equal to 0. And again, this is just for the domain. So take it, make sure that your radical is open to the x side, open to the side of the thing you just pulled out of the radical house. You solve these like you would solve a normal equation. Now, something you may have forgotten from Math 101, if you divide by a negative number, you have to flip the inequality. That's just if you divide by a negative number. So down here, where I divided by -1, that's what told me to flip the inequality. So I've got x is less than or equal to 5. Now in Hawks it'll say to write it in interval notation. So interval notation just says you have it written as an interval instead of an inequality. Now x less than or equal to 5 says that I want x's that are smaller than 5. So I go smaller and smaller and smaller and smaller. If I keep doing that forever, I'm going to get to negative infinity. So I have negative infinity to 5. Numbers for this section get brackets, infinities get parentheses. If you didn't flip the inequality and you had something like x greater than or equal to 5, if this was a different problem, you would have positive infinity to 5. So notice the order on this. I want to put it in least to greatest order. So this one over here on the left, the infinity comes first because it's negative infinity. This one over on the right, the infinity, that order is reversed. The infinity comes second because it's bigger. 5 is smaller. I want the smaller thing to be first. So just keep that in mind. But that's how you find the domain. And this is the answer that I want. The interval notation, in this case negative infinity to positive 5. Okay, so here's my second one. So I'm given the function f of x that equals square root of 4x minus 2. Find f of 6. So this is function notation. Function notation just says you take whatever that is and let x equal that number. So in this case, let x equal 6. So everywhere there was an x, I'm going to replace it with 6. So I'll have the square root of 4 times x minus 2, but x is 6. So I'll have the square root of 4 times 6 is 24, minus 2 gives me 22. Now this would be an example of one that the directions would say to write in radical notation. So radical notation means you're going to be left with a radical, unless of course it's a perfect square. So I'm going to do my factor tree on 22. I get 11 and 2. Can't break anything up anymore. Can't pair up anything. So my final answer is the square root of 22. And you would leave it like that. Again, that's because that is simplified. I don't want decimals unless it starts with I'm inputting some crazy decimal. Like in this example. So I'm given the function f of x equals the cubed root of negative 2x minus 3. And I want to find f of negative 7.6. So I have this decimal that I'm letting x be. So that thing says to let x equal negative 7.6. And again, this is because of function notation. So where there was an x, I'm going to replace it with a 7.6. So I have the cubed root of negative 2 times 7.6 because that was x minus 3. Now, if you're going to do it in your calculator, you have to do the inside first. So I'm going to multiply and do all that adding inside. And I got negative 18.2. Now I'll take the cubed root of that number. So that thing says that the cubed root of negative 18.2 is negative 2.6304. Now with that thing, the directions in here, if I'd written them all out, would have said to approximate to 4 decimals, to round to 4 decimals. So I would leave that with 4 decimal places. And so that would be my final answer.